Right, in this video, we are going to be going over delta to Y and Y to delta configurations when finding equivalent resistance within circuits. So in this first example, we are told to find the current flowing through the circuit. And looking at this circuit, we have a 12-volt power source, we have a 1 ohm resistor, and we have this configuration right here. So looking at this configuration, uh, none of these resistors are in series or parallel, right? So we cannot just add them up, or we cannot use the equation we use when two resistors are in parallel, right? And in order to be in parallel, two resistors have to share the same node. And looking at this two, for example, this two and this two are not, they do not share two nodes, right? And because there was this 4 between them, they share this node right here, but they do not share any other node because we have a 4 between them. And also they're not in series because they do not share the same current. So we cannot use any of those equations. So that's where the delta to Y equations come in. So for example, this delta right here, right, it's like a triangle, could be rewritten as, in general, right, it could be written as one of the resistors being called RA, RB, and RC, right? And that delta is also equivalent, directly equivalent to a Y configuration, whereby its resistors are R1, R2, and R3, right? And in this case, R1 will be the resistor between RA and RB, and in order to find that, you would multiply RA and RB divided by the summation, and R2 will be the left resistor, right? This one will be RA times RC. So the two resistors is in between. So you could think of drawing this configuration like in between, whereby R1 is gonna be here, R2 is gonna be right here, and R3 is gonna be right here, right? So in order to do that, it will be RA times RC. R2 will be RA times RC over the summation, and R3 will be the resistance in between. So R3 will be this one, the left one, the right one, which will be RB times RC over the summation. So if we apply that to this problem right here, we would find that R1, right? So looking at this, if you apply some, like a Y right here, R1 will be the top one, R2 will be the left one, and R3 will be the right one. And following these equations, you could see that R1 will be RA, will be RA times RB. So it will be the 2 times the 2 over the summation of all resistors. And R2 will be the resistors is in between, which is the 2, let me see, which is the 2, this 2 right here, and this 4 over the summation. And in this case, R3 has the same values as R2, so it would also be 1 ohm. So then looking at this, you would have a Y configuration that has R1 as 0.5 and R2 and R3 being 1 ohm. So looking at this, it definitely simplifies our circuit, whereby now we have R3, one sec, we have R3, this resistor right here, in series with these two, right? And we have R2 in series with these other two, right? So since they're in series, we would find that this portion right here, this part right here, would just simplify to, since they're in series, you can add the resistors. So you could add R3 plus the 2, R3 being 1, plus the 2, which is 3, right? And you would do the same for this, whereby it would be R2 plus the 2, which is the 1, plus the 2, which is the 3, right? And that goes right here. Actually, no. This goes right here, and this goes right here. So now we have a simpler circuit whereby this 3 and this 3 are now in parallel, right? So since they're in parallel, we could use the equation for two resistors in parallel, right? 3 is in parallel with the parallel, which is going to be the 3 times the 3 over the 3 plus 3, which is the 9 over 6, and which is about 3 3 halves, which is 1.5, right? So 1.5 is basically the equivalent resistance for this part right here, for this configuration right there. So that goes right here. And that simplifies our circuit even further, whereby now we just have a series configuration for this 0.5 and the 1.5. And so to find the total resistance for this circuit right here, it's gonna be the 1 ohm right here. Don't forget about that. Req will be the 1 ohm plus the 0.5 plus the 1.5. And this will give you about 3 ohms. And the goal for this equation was to find the current. So using Ohm's law, we could say I equals V over R, which is the 12 volt over the 3 ohm, which will give you 4 amps. So yes, and that is the answer right here.